The big shift this week is that AI systems are getting more capable and more fragile at the same time. On one side, agentic models are now being shown to trust forged metadata inside JSON, web pages, and tool traces enough to click, leak, or even run code. On another, linear attention is getting fast enough for long contexts without collapsing quality, while NVIDIA's audio text model shows you can add speech and audio without wrecking text reasoning. The common thread: scale is no longer the only story architecture, and trust boundaries are now the battleground. Let's explore the first paper. Agent data injection attacks are realistic threats to AI agents. Agent data injection attacks are realistic threats to AI agents, from Seoul National University and collaborators at the University of Illinois Urbana-Champaign and Largosoft introduces agent data injection, or ADI, a new indirect prompt injection class that does not try to override instructions, but instead forges trusted metadata inside agent data. The core technique is probabilistic delimiter injection, where attacker-controlled content in JSON, WebDOM, or tool response formats is misread by LLMs as structural delimiters, allowing fake objects, fake element IDs, spoofed authors, or fabricated tool histories to appear trusted. The paper shows concrete attacks on Anthropic's Claude in Chrome, Claude Code, Claude OpenAI Codex, and Google's Gemini CLI, arbitrary click attacks on web agents, remote code execution through Origin, spoofing in GitHub issue comments, and supply chain attacks by injecting fake tool call and response blocks into pull requests. In isolated LLM tests across GPT-5, 2, GPT-5 Mini, Claude Opus 4.5, Claude Sonnet 4.5, Gemini 3 Pro, and Gemini 3 Flash, baseline ASR reached 31.3%, 43.3% on JSON, and 33.3% 100% on WebDOM, while randomization dropped JSON ASR to 0% 3%. On Agent Dojo, instruction injection stayed near 0 at 0%, 0.7%, but ADI reached up to 50% ASR. Only CAML strict fully blocked it, at the cost of utility falling from 86.5% to 36.5%. Let's explore the second paper: linear attention architectures, mechanisms, trade-offs, and cross-layer routing. This ETH Zurich study unifies softmax attention, DeltaNet, gated DeltaNet, Kimi delta attention, and gated DeltaNet, two in a recurrent memory formalism that exposes a clear trade-off between expressivity, memory decay, and write control, then test that design space on 350M parameter models trained for 15B tokens on FineWebEdu with the Llama 2 tokenizer. In the main sweep, Kimi delta attention with Muon in a hybrid stack achieves the lowest final validation loss at 2.273, while pure gated DeltaNet with AtomW is the fastest normalized training configuration at 100% relative speed, but ends at 2.433 loss. Muon consistently improves matched loss across all families. Hybrid stacks usually lower loss but reduce throughput, and long context scaling strongly favors pure recurrent stacks. At 32K tokens, iteration time is 3.37 seconds for softmax, 1.56 seconds for gated DeltaNet hybrid, and 0.96 seconds for pure gated DeltaNet. The paper's routing contribution is more novel than the base benchmark sweep. A DeltaNet-inspired cross-layer error residuals path does not help, but cross-layer value routing, which injects the right value into the shared residual stream through a zero initialized projection, yields small but consistent validation loss gains, including a 0.0103 drop for gated DeltaNet and a 0.0119 drop for DeltaNet at 350M. 1B, with smaller improvements persisting at 15B tokens and in a 1-3B 40B gated DeltaNet run. Let's explore the third paper: unified audio intelligence without regressing on text intelligence. NVIDIA's Nematron Labs Audex 30B A3B, or Audex, is a unified audio-text large language model built on the text-only Nematron Cascade 230B A3B backbone, designed to handle audio understanding, speech recognition, speech translation, text-to-speech, audio generation, and speech-to-speech in a single transformer decoder without the usual text regression seen in multimodal systems. The model projects audio embeddings into the text space, then autoregressively predicts text tokens plus discrete speech and audio codec tokens and it is trained with a large mixed corpus of 157 4B audio tokens and 325 B text tokens across 394 M samples. Audex preserves text intelligence nearly intact while improving key text reasoning benchmarks, reaching 91.2 on AMI 2025 and 92.2 on HMMT Feb 25 with tool use, while also setting strong audio results such as 75.6 on MMAU, 6.82 WER on OpenASR, 34 BLEO, 86.9 COMET on Fluor's speech translation, 1.7 WER on Seed TTS Evol Fixed Voice TTS, 66,9 on Audiocaps FD OpenL3, 62,7 on Song Describer FD OpenL3, and 90 on Big Bench Audio. The architecture uses a 30B MOE backbone with 3 B-activated parameters, a 52-layer hybrid Mamba transformer design, 128 routable experts, and a 205,312 token vocabulary, after adding 65,536 speech tokens and 8,192 audio tokens. NVIDIA reports training on 512 H100 GPUs and favors a multi-stage SFT curriculum because single-stage consolidation nearly breaks long context behavior, collapsing NIA from 99.3, 86.8 to 6.0. That's a wrap on today's AI paper highlights. Thanks for watching.